Welcome to another teardown video. This time it's a signal generator. I don't know yet how old this is. I'm not able to find a manual or any information on the internet. I saw another video explaining just very briefly how it worked, but I'll go a little bit more in detail, so I hope you enjoy this. So as far as I can see, we got 5 ranges of frequency. We can lag or lead the phase, and see how smart they made the yellow here. So this is the output with the variable phase, where you can lag or lead it, and this is of course the non-modified phase output, and this is the voltage, variable voltage, times 1.1 or 0.01, so you can make it a really low signal level. At least this is what I think. See here, what is this? So here you can variable a square wave or a triangle wave. Is this in or out, or is this controlling? I don't know yet, but I would think this would be output for syncing or scoping or something. Let's see on the back. They come in different versions, also one with a mains filter and with a mains plug. This one is just a wire out of it. Thankfully, they inform about the voltage, so that is fantastic. See the sync or the voltage control, so internal or external. So, but where's the ground for this? This is something, or maybe this is a jack connector, but it looks like a banana. So I'm a little bit worried about what this type of connector is, because it does not look like there's a signal and a ground. So we need to open it to figure this out. Let's leave it in internal. Let's first we test it and then we open it, right? So before powering this up, I took the liberty just to ohm the outputs. See, 600 ohms, and it is not affected. Yes, see it is. And this is one of the outputs. It is really affected by this switch. But if I take the other channel and do the same, still the same 600 ohms. That is a little bit funny, isn't it? So I believe something is wrong with one of the outputs. And one other thing that I find a little bit interesting is that the 2 outputs, they're floating. How cool is that? So this is the common for this output, and this is the common for that output. Really? How cool is that? I really need to investigate a little bit more into that. So if this one is the common, it says earth and common, and then I try to measure to those. So that's 10 K to that one. And this seems to be, there's like a capacitor or something on that one. So that is a little bit funny. All right, let's try and power it up. No. Let's turn on the 5 watts. Okay, and there's light. And if I turn this off, it goes to 0. Okay, so this is truly a mains breaker that will remove all power. Okay, great. 5 watts. So let's connect the scope. And of course, this thing is just as broken as it can possibly be. And this is of course why I get stuff. And of course, it's more fun that way, isn't it? See, this is the voltage output. It actually does react to the kind of attenuator setting here, but this one doesn't really, not that much. And here is the output here is, look at that. So this is the phase that kind of just, and then it goes back. It looks really weird. So there's something going on that is just weird on this channel. And then the frequency, however, is, so that is up to 1 kilohertz, and this is like 10. So the frequency is just amazingly accurate. So, and if I go 10 down, let's see, 99. How about that, huh? So the frequencies there are all right. I don't see anything here. And the other output is just completely broken. Let's have a look at that. See, this is the same range. I get some, and if I move this switch so it's in between settings, then I can get something that looks like this. So that looks really, really bad. And of course the frequency is right. And then it is moving a little bit like this and then back again. So I don't know what that is really. I am not impressed so far, but of course it's broken. What the heck just happened? By connecting the 2 grounds together of the 2 common outputs via my scope, now channel 1 is a sine wave. How funny is that? So that means a broken ground wire in here that actually supplied the output driver circuit is kind of broken or burned. How funny is this? Have you ever seen a fault like that? Alright, so we have sine wave out on channel 1, but the other one is still a really, really weird one, and it's not affected by this. So there's a blown out output circuit driver here or something. And then look, there's also something, when I move the phase, it's affecting the output. Look at that. Really, really weird. That, I guess, is not supposed to happen. So that means the signal is, yeah, there's something, definitely something. And then this is the lead or lag, and then it goes the other way. Okay, so that works. And this is the frequency, yeah. All right. So we need to open this and figure this out. And then we can also understand the nature of this type of connector. What is that? I just took my chance with a hook wire like this. And look. So this one is a variable square wave, exactly as the symbol says. So variable square wave out on that one. Let's go see. And what have we got? And that seems to be working. And look. So this is the main channel. Those are frequency and or phase locked to the main channel. So far we got life in some form and shape, and now we can adjust the phase because we're looking at the other one here, right? So that's great. Let's open. Trying to get into this unit is a little bit difficult. What I did was not necessary to take out the screws from the back. Of course, you need to take the screws out here from the sides. See here in the side, this is where you have the handle. Inside the handle, there are hidden screws. Those two screws lock together the top and the bottom part, and they're hidden. And of course, this was broken and repaired with glue. The idea is, in the other one here, you can see there is a hole, and this plastic cover goes in here and kind of hides the screws. Somebody added this as a solution. Pretty cool, huh? So now you can press this in and it will stay in and it will hide the screws. Alright, so now we can go in. You need to lift this thing. Why is that so difficult? It should be... there are no more screws. Yes, god damn it. We're in. And look at that. Everything is lined up. Beautiful. That is an amazing job. And look at this silk screen. Even a half-blind who forgot his glasses can read the numbers. I love it. Because I'm getting old and blind, so this is really the kind of PCB layout I love. This is just fantastic. Look how big this is. Everything is just big and good. And those capacitors, they're not really, see here, they're not really that big. And they mounted them with a cable tie. So I guess this, you can drop this from a plane and it will still work. Look at that. That is quality. And again, mains is connected to the chassis with the earth wire, and the front also connected to earth. Good for safety. And look at this. This is the on-off switch. So this is located at the rear near the transformator, and the mains voltage switch is hidden inside, so nobody's gonna change this by accident. Fantastic. Voltage regulators for everything, and this is the oscillator circuit. This will be the oscillator range switch that goes to this op amp of 30 something. This looks like an op amp, right? Op amp and some transistors and some stuff. So this is the oscillator, and it looks a little bit like it is configured as a double oscillator. So that explains its capability with the phase shift. And oops, what is that? Did you see it? Yeah, that is exactly what I think it is. How are we gonna go and get light in here? And yes. Look at that. Because I said that I needed to connect the two grounds together, and then one of the outputs actually worked. And of course it's working when there's ground on the output system. You see? So that is something we need to recover. And also, there's only ground. If this is even connected, there is no ground. There is no ground wire to the top output, see? So this system only works if you connect the two grounds together. This is how it's designed. That cannot be what you want. So I suggest we mount a wire from this ground and to the other ground. And then we'll see what happens and recreate this one. I bet there will still be this error in one of the outputs. So I bet one of those transistors here in the, this is the output driver. And one of the output driver there will be a shorted transistor here, or a broken something in this output driver. Oh, look at those. Uy, uy, uy. Transistor 16, 17 something. Ooh, those are integrated transistor packs. That is some nasty stuff. That is exactly what it is, and just some standard op amps. I really like this switch. Look at that one. Beautiful. And this is just top quality potentiometers. Everything here is really, really nice top quality. I really like that. We are back, and look at this. All I did, that's actually two of them, right? See? Haha. All I did was connecting the two grounds together and connecting the missing wire. I don't know if that's easy to see, but now the two grounds here are connected together permanently, and now it works. Haha. Look at this, how they numbered all the analog circuits. So they're called A, G, A, F, and so on. AC is this one. AD. I just love it. And over here. So this continues all the way around. I can't really say anything about how old this is, but I think those regulators, this 8541, I think this is the year and week code. Please correct me if this is wrong, but I believe this is 85. What else did I find? Yes, I found something else that was really, really funny. Look at this. So this is because, look what they did. Because this is a plastic case and it's an analog circuit, you want to shield this from all sorts of electrostatic fields or hum and such. So this is painted with electrically conductive spray paint. Isn't this just nice? And this is also done on the inside of the case. And this is connected. I don't know if we can see this, but it is connected to the ground. There's a ground track all the way around. It's also connected up from down here. I should be careful not to touch anything here because this is still powered. Yeah, so that is what I wanted to say about this beautiful unit with the really, really nice layout made by Jackie. Great.